Before working with trigonometry in 3D, we have to define some things about angles in 3 dimensions. First, let us define what is meant by the angle between two planes. And so we have to find out how is this angle defined. Let us start by looking at the line of intersection of these two planes, and then let us draw a line in the first plane here that is perpendicular to the intersection line, and another line in the other plane that is also perpendicular to the intersection line, and that intersects with the other line L1. And now the angle between the two lines L1 and L2 is just the angle between the two planes. To understand why this is the case, let us turn the whole situation such that we look directly into the line of intersection L. This means that the line becomes just a point. Let me now write this down formally. Let L be the line of intersection of planes P1 and P2. Then the angle between the planes P1 and P2 is defined as the angle between the lines L1 and L2, where L1 lies in plane P1 and L1 is perpendicular to line L. Line L2 lies in plane P2 and is perpendicular to the line L, and L1 and L2 intersect. Now we want to look at the angle between the line L and the plane P. Now we want to look at the angle between a line and a plane. So we have to find out what is meant by the angle between a line and a plane. Let us mark the point of intersection S between the line L and the plane. Then let us choose an arbitrary point A on the line A. And we want to find the projection of the point A on the plane. Projection means we take the line perpendicular to the plane passing through A, eine Senkrechte, ein Lot, from A to the plane, and where they intersect, there we have this projection point A dash. We connect then the point S and the point A dash, and we get the line L dash, and the angle between these two lines is exactly the angle between the line and the plane. Another way of finding this angle is to take the normal line to the plane, this means the line perpendicular to the plane, passing through the point S, and then have a look at the angle between this normal line here and the line L, and we see it's 90 degrees minus the angle that we're looking for. So if we find this angle, we can just take 90 degrees minus it, and we'll find alpha. Let us visualize this by turning the situation such that the plane becomes just a line. Let us formalize this again. Let A be a point on L and S be the intersection point between L and the plane P. Let then A dash be a point in the plane P such that the line AA dash is perpendicular to the plane P. And then let L dash be the line connecting S and A dash. And let N be a line perpendicular to P and passing through S. Then the angle alpha between the line and the plane P is defined as the angle between the line and L star, or as 90 degrees minus the angle between the line L and the normal line N. Let us now look at two examples. Start with example 1, read it and try to solve it by yourself. So stop the film. And here comes the solution. Let us name the apex of the pyramid S, the center of the base face M, B this vertex, and A here the midpoint of this edge. To find the volume of the pyramid, we need to find the height of it. In task A, we're given this angle alpha here, it's 40 degrees. So what we can look at is this triangle here. I have redrawn it here, and we know that this angle alpha is 40 degrees. This is the height h, and this is 3.5 meters long since it's half the edge. Relative to the angle alpha, This is the opposite and this is the adjacent. So opposite and adjacent occur in which trigonometric function? Right in the tangent. So the tangent of 40 degrees is h divided by 3.5 and hence h is 3.5 times tangent of 40 degrees, and we get for the volume 1/3 times 7 squared for the base and times 3.5 times tangent 40 degrees for the height, and this is approximately 48 cubic meters. In task B, the angle beta here is given, so we look at this right angled triangle, it's drawn here. We see here we have the height h, and this length here, MB, is just 3.5 times square root of 2, since we have an isosceles right-angled triangle with side 3.5. When we compare the triangles in A and B, we see that they are equal except for this side length being now 3.5 times square root of 2, so we can formulate directly the formula for the volume. The first part remains completely unchanged, 1/3 times the base face area, 7 squared, and then times the height. Well, it's now not 3.5 times tangent 40 degrees, but 3.5 times square root of 2 times the tangent of 40 degrees, and we get approximately 68 meter cube. Now have a look at example 2. And attention, this here should say slant line, in German Montellinie, meaning any line going from the apex S to any point on the base circle radius. Try to solve the example on your own, so stop the film now, and here comes the solution. We can look directly at the triangle SAB. The side SB is the longest slant line, and the side SA is the shortest slant line, so they are 9 and 7 long. And the length AB is the diameter of the base circle, so it is 10 centimeters long. To find the volume of the cone, we need to find its height. Using trigonometry, we can find this height h if we know this angle alpha, since we have a right angle here. Well, how can we find this angle alpha? We have a triangle, we know the 3 sides, and we want to find an angle. We have to use the cosine rule. And so we get that 9 squared equals to 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of this alpha. To solve this for alpha, we have to subtract the 9 squared, we have to add the 2 times 7 times 10 times cosine alpha, and once we have this all on the left-hand side, we'll divide by this 2 times 7 times 10, and we end up with this expression. To get alpha, we have to take the arc cosine of this expression, which is in the end just 68 divided by 140, and we get for alpha approximately 61 degrees. To find h, we look at this right triangle. We have the hypotenuse here, and h is the opposite of this angle alpha. So opposite and hypotenuse, this means we need to use the sine. And we get sine of alpha is h divided by 7. So h is 7 times sine of 61 degrees. And hence the volume is 1/3 times the base face area, pi times 5 squared times the height, so approximately 160.3 cubic centimeters.